Welcome to another exciting episode of Mr. Takeda Teaches Algebra for the year 2020. I'm your host, Mr. Takeda, and I'm going to teach you some algebra right now. This is lesson 3.1 on functions. Hey, what the heck's a function? Well, we're going to start off with vocabulary here, so make sure you get these in your notes. You can pause this to write these down. I'll read them and talk about them a little bit, but if you need to pause the video to write these into your notes, please feel free to do so. Number one, a relation is a set of ordered pairs. And hopefully you know ordered pairs are things where you are examples like 2, 3, and then we put them in parentheses. And a set of these would be separated by another comma, and there would be like 4, 5. So right now, so this is a set of ordered pairs. Sometimes you might see these also like in little braces. We call those braces. That's part of like set notation. It could have those or not, but basically a set of ordered pairs is called a relation. A function is a relation where each member of the domain is assigned to one and only one member of the range. Okay, write that down. We'll talk about that in more detail moving forward. Okay, the domain is the set of first input value. So in this case here, the domain would equal 2 and 4, because that's my input values. So the first values, we'll call them the x values, right? These are x and y. So 2 and 4. The range then would be what? The 3 and the 5. Okay, so get those into your notes and pause it if you need to, and then move on to what we call about functions. Okay, so functions, like we said on functions, let's go look at the definition one more time. A relation, so it's a set of ordered pairs where each member of the domain, that's the first value, is assigned to one and only one member of the range. Okay, so functions can be described in many ways by an equation. We'll be dealing with those a lot. By an input-output table, where you see the x and the y values either side by side or one above the other. By using words, sometimes we'll look at those and convert those into equations or input-output tables. By a graph, and here's a graph over here, we'll look at that in a second, and as a set of ordered pairs, and we saw what one of those might look like. A says, explain why the graph shown represents a function. Describe the function in 2 other ways. Okay, so let's take a look at this here. So first of all, each of these points has an x and a y value. So this would be 0, 8, right? This is 0, 8. And this would be 1, 6. This would be 2, 4. This is 3, 2. And finally, we have 4, 0. Okay, so right now we can see that every member of the domain, 0, 1, 2, 3, 4, has a unique member of the range. So for 4, it's always 0. For 3, it's always 2. For 2, it's always 4. For 1, it's always 6. And for 0, it's always 8. That's why this is a function. This graph represents a function. And we'll describe the function in, well, for right now, we're just going to describe this function as a set of ordered pairs. And those are the ordered pairs there. I don't want to waste too much time in going on the other ones because we're going to look at those in a second. And seconds right now. So this is example 1 from page 104, in which we determine whether the relation here is a function. Okay, so again, we want to look at the input values. -2, it goes to 2. -1 also goes to 2. But that's okay because, well, we'll look at what is what is not a function in a second. But I'm going to just tell you this is okay. Because 0 always goes to 2. Let's use that word. 1 always goes to 0, and 2 always goes to 0. -1 always goes to 2, -2 always goes to 2. So this is a function. And the explanation, again, is every member of the domain only goes to one member of the range. But let's look at example 4 here. And specifically here and here. Right? So we have the 4 as the member of the domain twice. But in this example, in this ordered pair, 4 is assigned to 0. And over here, 4 is assigned to 3. So this is not a function. And the explanation is, again, the number 4 in the domain has 2 members of the range paired with it. Okay, so that is not a function. So the same, that's what we're going to be looking for in this input-output table here. So essentially what you're kind of looking for is you're looking for this kind of case here where you have the input value twice. This is our input value twice. Is it paired the same each time? No, we have 0, 5, 0, 6. So this is not a function. Over here at D, -1 goes to 4, that's fine. 3 goes to 15, and 11 goes to 15, and that's okay too, because again, in the domain, each of these appear only once. It doesn't matter what they're paired with, as long as they don't appear more than once and are paired with 2 different members of the range. So this is a function. Okay, so try these. There's 2 questions here. You'll be asked in at the end of the pod whether or not for your answers on these. So for 1 and 2, is it a function? Is it not a function? Basically, yes or no. And you pause this if you need to look at these, and once you're ready, move on. The vertical line test. So let's talk about the graphs again. The vertical line test, look at the words. It's basically says that a graph is a function when a vertical line, when no vertical line passes through more than one point in the graph. So for example, this one is a function because this vertical line will only pass through one member, one point on the graph at a time. Where over here, this one's not a function because this vertical line passes through the graph twice. What does that mean? Well, it means for this input value, or x equals whatever this is here, I've got 2 y values. I've got x, we'll call that x, y sub 1. And over here, it's the same x value, but a different y value, a greater y value. So having the condition of not being a function will cause a graph where will cause a graph where a vertical line will pass through more than one point at a time. Okay, so that's the vertical line test. So we'll use the vertical line test here to determine whether the graph represents a function. Okay, I'm going to start by drawing a vertical line. Now this vertical line is not going to be great because, well, I don't have a snap to tool on this thing apparently, and maybe I do, but I can't find it. Okay, so if I pass this vertical line through right here, you can see this vertical line passes through 2, 2, and 2, 5. And right here you can see it's going to pass through 5, 1 and 5, 5. So this one will not be a function. It does not pass the vertical line test. My crummy vertical line, sorry. I'm still learning to use these tools. And over here, this one is a function. Now remember, a line is only a series of points that are all connected. So this one, it does. This one is a function. B is a function, A is not a function. Example 3 on page 106, find the domain and range of the function represented by the graph. Okay, so pretty straightforward. I gave you an example on this earlier. So we've got some points here. This is -3, -2, -3, -2. This is -1, 0. This is 1, 2. This is 3, 4. Okay, so definitely a function. So the domain here, is going to be just represented. I put a D colon, and we just list them out. -3, and the order doesn't really matter. -1, 1, and 3. Okay, so those are our x values, and then the range, instead of all the y values, the second value is -2, 0, 2, and 4. Okay. Now over here, this one's going to be a little harder to conceptualize here because this is a continuous graph. The x values go from, the lowest x value here is -2, right here, -2. This is -2, -1. And this one is 3, 2. Okay, so, but since it's continuous and we're dealing with domain, that's our x values, we're going to use our compound inequality notation. That x is what? It's greater than -2, and it's less than or equal to 3. And over here, I should have said x is greater than or equal to -2. Now, in the range, well, the high range value is 2. The low range value here is -1. So, same thing. Y is greater than -1. All the whole graph is above this point. So it's greater than or equal to -1. And down here, the graph is below or equal to 2. Okay? Those are my examples. So you make sure you get these. You have to kind of recreate these pictures in your notebook. And otherwise, that's it for today. And we'll finish this one up in class in the next couple days. I'll see you in class. Bye-bye.